My name is Andreas Zeller. I'm a researcher at Saarland University in Germany, and I am researching large programs and why they fail. I have done some fair work in automatic debugging, also in mining the histories of programs. I've been working with companies such as Microsoft, SAP, or Google, examined their bugs, finding out what was wrong. And it struck me that there's almost no teaching material available on debugging and how to debug programs. So today, I'm going to start with you a course on how to do debugging systematically, effectively, and in many cases, even automatically. Enjoy. Welcome to the Udacity course on debugging. The aim of this course is to teach a systematic approach to debugging. And we're even going to explore a number of automatic tools that do the debugging for you. We're going to explore how debuggers work, in particular the scientific method of debugging, by which, through a series of experiments, we gradually refine a hypothesis until we end up with a diagnosis on why the program fails. On top of that, we're going to build our own interactive debugger in Python. In the next unit, I'm going to introduce you to one of the most powerful debugging tools ever invented. That is, assertions. Assertions are statements in the program that automatically check whether the state of the program is still correct. That is, while your program is executing, the computer constantly monitors the program on whether a bug has occurred. This allows you to very quickly and effectively find out where a bug was first introduced. On top of that, we're going to build a tool that makes you infer assertions from executions. In Unit 3, I'm going to show you a technique named delta debugging, which automatically simplifies problems. For instance, here's this 900-line HTML file, which causes a crash in a program which processes it. With delta debugging, you can reduce this to just the 8 characters that produce the bug just as well. And all of this automatically. In the next unit, I'm going to show you how to find out where a specific failure came from. If you see an execution as a series of states, we're going to explore techniques that help you tracking the way of an error all through the program execution. And on top of that, we're going to build a tool that isolates such cause-effect chains automatically. In Unit 5, we'll be looking at reproducing failures. We're going to look at all the various input sources for your program and discuss how to capture and replay them such that you can faithfully reproduce a failure that happens in the field. Plus, we're going to explore statistical debugging, which collects data from the field to tell you which parts of your program are most likely to be related to the failure. In Unit 6, we're going to see how to mine information from bug databases and change databases in order to figure out where bugs have been in your program in the past, where they accumulate, and which parts of your program, therefore, are going to be the most bug-prone in the future. And again, this is a fully automatic technique. If so far you've had no fun in debugging, because, well, it just sucks the life out of you, the aim of this course is to get most of the debugging effort off your shoulders, because you can have the computer take care of most of the debugging work. So your mind is free for doing something more creative than debugging.